The 2020 Nobel Prize in Physics was awarded one half to Roger Penrose, the other half jointly to Reinhard Genzel and Andrea Ghez. The prize was awarded for the discoveries related to black hole. So, what actually black hole is? A black hole is a place in space where gravity pulls so much that even light cannot pass through. Because no light can pass through, people cannot see black holes. They are invisible. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than the other stars. Black holes are mostly formed due to the dying stars when the gravity overwhelms nuclear fusion, which pulls everything to its center, creating a space-time singularity. Gravity is so strong because the matter has been squeezed into a tiny space. Now presenting Roger Penrose's work. Roger Penrose has been awarded the prize because of his theoretical work, which showed the black holes can form and exist as solutions to Einstein's field equations. Penrose also shared the Wolf Prize for Physics with Stephen Hawking for his work on the Penrose-Hawking singularity theorems. Albert Einstein published his general theory of relativity on the 18th of November 1915. Soon after that, 13 January 1916, German astronomer Karl Schwarzschild found a solution to his equation that showed a singularity. When a mass is compressed to Schwarzschild radius, it exists as a black hole. That is, Earth's Schwarzschild radius is 9 mm, which means the mass of the Earth is compressed to 9 mm, it exists as a black hole. R equal to 2 gm. When R equal to 0, singularity exists. For a long time, this was a bit an embarrassment to Einstein, as it is appeared his equation had unphysical solutions and may not be correct. In 1939, Robert Oppenheimer and his student Hartland Cinder came up with a paper which they identified and interpreted Schwarzschild's result as a horizon beyond which star closes off and can be felt by its gravitational field. However, Einstein did not agree with this yet. Singularity, Penrose, Hawking. Once we accumulate enough matter to form event horizon, the matter must lead to singularity within the event horizon. Here, event horizon is boundary defining the region of space around the black hole. To describe this mathematically, Penrose used a topological concept, trapped surfaces. These are theoretical surfaces in which light can't reach boundary but always converges at a point. The Penrose process explained the mechanism how a black hole develops to lose mass emitting energy. This can explain the astronomical phenomena known as quasars, in terms supermassive black holes. Two independent groups of observational astrophysicists led by Professor Genzel and Professor Ghez have been monitoring the center of the Milky Way for nearly 3 decades. They were studying the compact radio source Sagittarius A star near the galaxy's center, which is known to be the supermassive black hole or the supermassive compact object. Sagittarius A star is 25,000 light years away. In a distance of 26 million light years, only one photon of billions of photons, which will reach us due to our own atmosphere and interstellar dust and gas. By choosing a different wavelength of light, that is a near infrared, which will lead 1 of 10 photons to reach us. Just imagine their challenging experiment from this greater distance of 25,000 light years, identify and track individual stars and not to be distracted by interstellar dust. Yet they managed to keep tracking the stars near the Near Infrared Telescope and successfully proved the mass was indeed concentrated at the center Sagittarius A star. They spotted stars which the teams named S2 and SO2, which orbited Sagittarius A star in 16 years, taking the elliptical orbit. The interpretation of this was the Sagittarius A star indeed a supermassive black hole, as it was massive 4 million times mass of our sun and rather small. Also proved the hypothesis that every galaxy would have a supermassive mass at its center.